Welcome to the lesson 9 of the Advent of SysML v2. This is a training series consisting of short videos and exercises brought to you by Sensmetry in collaboration with Vince Molnár. My name is Kestutis, and today you will learn what are the challenges in managing and reusing SysML v2 models across wide and distributed teams, and how Sysand, the open source package manager for SysML v2, addresses them. As your SysML v2 projects grow beyond single engineer working in isolation, you'll encounter familiar problems. The same subsystems get modeled over and over again. Sensors, communication modules, each project recreates them slightly differently. This results in incompatible variations. Another example is you receiving models from suppliers with version mismatches. One vendor uses version 1.2 of your interface definition, while another one uses version 1.5. Models don't align, and you spend valuable time debugging incompatibilities. And last example, your organization established modeling guidelines, but getting everyone to follow them consistently is a challenge. Each project drifts further apart from the baseline. These are not new problems. Software engineers have solved them decades ago with package managers such as npm for JavaScript, pip for Python, and others. They are tools that manage, version, and distribute reusable libraries for those languages. The question is, can this approach work for SysML, for systems modeling? The SysML v2 and KerML standards define two collaboration approaches. First is API-based, and second is package and manager-based. Sysand is the first real implementation of the package and manager approach that brings proven software engineering practices to systems modeling. It gives SysML v2 models a modular structure through reusable libraries. This ensures teams use the correct versions consistently and provides a unified way to distribute and consume model assets. So in summary, Sysand helps teams manage, share, version, and reuse model libraries with the same discipline that software teams apply to code dependencies. So why does this matter for systems engineers? Consider these scenarios. For design, your spacecraft team models bus architecture for every mission. You publish it as version package that every new project imports. When you improve the design and bump the version, other teams deliberately update the model dependencies rather than copy files around. For compliance, your automotive OEM maintains strict modeling standards for safety-critical systems. They are published as an official package. Every new vehicle project imports them, the same baseline, and thus automatically stays aligned with the requirements. You are integrating subsystem models from 3 different suppliers. Each delivers their work as a package with explicitly declared dependencies. When they update interface definitions, the new version propagates cleanly to your integration environment. And for speed, your team is prototyping under tight deadlines. Package management lets you use existing, proven model libraries rather than building everything custom and from scratch. Import testbed components and focus on what's truly novel. Package management is not just about making modeling feel like software development. It is about solving real collaboration problems that emerge when engineering work scales across distributed teams, multiple suppliers, and complex organizational hierarchies. So now, let's see how Sysand works in practice. On the left, we have VS Code with our Santa workshop model from lesson 3. On the right, we have public Sysand package index that we just mentioned earlier. So here you can see all the packages that are currently available for everyone to use. What we want to achieve is to use PLAML package, and you can see that is currently not available in our workspace, but it is available on the Sysand index. So to get access to it, what we do is we need to initiate Sysand project. So we do Sysand init, and we download this package by copy pasting this command. So we copy paste, and there we go, we now have it installed. We can reload the Syside language server, and you can see now library package is available. We can go to definition and we can see all its contents and everything that it contains. To check the state of our Sysand project, we can also type Sysand info. So you can see that we have one dependency, plan, and then if there was this package dependent on other packages, it would also be listed here with sub-dependencies. If we want to publish our Santa Workshop project as a Sysand on Syside index or on private index, we can also build it into this kpar file. So what we do is do then Sysand include our SysML file of interest. So that will be lesson 9 Santa Workshop, and we type Sysand build. So now you see this output folder produced with the kpar file. If we open it with File Explorer, you'll see that it contains our SysML workshop and project related information. So there you have it. This is the Sysand package and how it works. Package management becomes even more valuable when you think beyond individual projects. Imagine a collaborative SysML v2 ecosystem where teams can discover, share, and build upon each other's work. Consider how open source software thrives. Developers import well-tested libraries and focus on solving novel problems rather than reinventing the wheel. The same pattern can transform systems modeling. Instead of building sensor models, communication protocols, or domain ontologies from scratch, proven implementations could be shared as packages. The Sysand package index at sysand.org aims to serve as this central hub. Engineers can search there for existing packages before starting from zero. A satellite team may want to import orbital mechanics package. An automotive startup could leverage industry standard electrical architecture libraries. Academic researchers could publish the reference models that others could build upon. More importantly, shared packages enable true interoperability. Just like USB-C allows devices from different manufacturers to work seamlessly, shared model packages let teams integrate components developed separately. When everyone builds using common standards and interface definitions, integration work becomes straightforward. This ecosystem also benefits from network effects. As more teams contribute packages, the value grows for everyone. Someone who solves a problem today and publishes a package may save many hours for many people who need to solve the same problem tomorrow. To conclude, you learned how Sysand, the first open source package manager for SysML v2, enables management of model dependencies at scale. And today, your challenge is to initialize a new Sysand project, add a few dependencies from public index, and build it all as a new package. Go to blog post to see full task details. Share your results in the community forum, and feel free to ask any questions about this or any past lesson. Links and information on how to get free access to Syside Cloud Platform are in the video description below. Subscribe to our YouTube channel and click on the bell icon to get notified about future lessons. Tomorrow we'll continue with more SysML v2. Take care and happy modeling!